Hey, it's another edition of XI to I. I'm Mike Gibson. I am a designer here at Table XI. You can find me on Twitter at Love Has No Logic, and as always, you can find Table XI on Twitter at Table XI. Today, we're going to be talking about something that I've been using quite a bit lately, and it is the VW. No, I've not been driving all over the city. VW is part of the viewport measurements available in CSS. This is VW, VH, VMin, a whole bunch of cool stuff that lets you size things based on the size of the viewport. And I'm going to talk about how specifically we're using VWs to control the size of our type to create fluid type in the same way that we create fluid images in our responsive designs. So what is a VW? If we look at this right here, we have 100 bars going across the screen. 100 VW is always equal to the width of the window. So if you want something 100%, 100 VW is the same thing. The cool thing about it, if you're using it on box model properties, such as the width of an item, it does not get affected by things like padding or margin. So it's always a true 100%, which is always really nice. But what this means, if 100 VW is equal to the width of the window, then 1 VW is 1% of the window width. So the screen bar that you see here on the screen is 1 VW. So as we start to think about that, we realize that we can use this to control the type in our document. What does this actually mean? So if we're looking at it, depending on what the size of our browser is, 1 VW is going to be a different measurement on the screen. So at 1000 pixels wide, 1 VW is going to be 10 pixels. At 750 pixels wide, 1 VW is going to be 7.5 pixels. And as you can see, that continues no matter what VW unit we throw at it. 3.2 VWs is going to be different sizes on a 1000 pixel screen and a 750 pixel screen. It's pretty cool, but it's also not really how we think about type as designers. We're not sitting here doing our designs thinking about type in relation to the page itself or in relation to other boxed elements on the page. We typically will think of type in relation to other type. So this headline should be X% bigger than the body copy, so on and so forth. That is where being able to use these viewport widths in smarter ways, but knowing how to target them comes in extremely handy. So we actually are in a good situation because we're using SAS on all of our projects, and we can do that. If we remember, we have three parts. We have the browser width, we have the end result, the target size of the type, and then we have the VW unit, which makes that relationship between the two. And what we do is we use this custom SAS function that we wrote. We have a SAS function that we call VW. We pass it two of those three known values. We pass it the target size, what size we want it to be, and we pass it our breakpoint. We pass it the point at which we want it to be approximately this size and then be fluid based on that target. What the function does, it takes those two values and gives us the third value, the unknown in the equation. We don't know if it's 3.2 VW or 3.19857 VW or 3.05943 VW. Those are all really crazy, silly numbers that we don't want to be worrying about. What we do want to be worrying about is the things we know and let the computers give us the rest. You can see it here in use. I'm just writing some CSS here for an H1 element. And we're saying, okay, we're building a mobile first site, so it's small sizes. Let's go to target of 16 pixels, and will be fluid within that range until it hits this first breakpoint where we reset that target to be approximately 24 pixels instead of approximately 16 pixels. And then it will continue to be fluid until it hits another breakpoint and gets calculated again. I can show you the math right here as well. A little bit, you can see that the numbers we give it just get slotted into our function, and we get values in return. And as you can see, at the smaller sizes, it's 3.2 VW, so it's a bigger number than at the larger sizes. But because of VW is a relative size, the actual type is going to be much larger at that larger size. We're going to look at an example here of this in a second, but remembering all these numbers, remembering where these breakpoints occur, sometimes, it's not fun. You don't want to keep track of all of this within an entire project. So we can actually make this a little bit easier by just using variables for our breakpoints. So we just name our breakpoints, 1, 2, 3, so on and so forth. And then we have the exact same CSS, but now we can set our target sizes based on which breakpoint we're hitting. Breakpoint 1, breakpoint 2, breakpoint 3. We don't have to remember exactly what those values are. Makes working with this stuff extremely easy as we apply this to an entire design system. So if we look at this example here, you'll see the type grows and shrinks as the browser grows and shrinks. The relative line length is always going to stay the same throughout because we're sizing the type relative to the viewport width. You can see I also have one breakpoint in here that I'm using to resize to apply a new VW unit to the type as we go through as well. So throughout the entire design, we have 100% fluid type that we can control as finely as we want to just by adding additional media queries and using our Sass function to add a new VW. Pretty cool here. If we're looking here at our browser support for VW units, we only got really 3 areas where we need to be concerned. First off is Internet Explorer. Surprisingly, IE9 and up support VW units. So if you're supporting IE8, you need to supply a pixel value as a fallback, and then you can supply your VW sizing. IE8 is going to ignore the VW and stick with the pixels. The other major concern here, browser-wise, is going to be supporting the Android browser. 4.4 and up are the only Android browsers that support the VW unit. This is obviously the stock Android browser that I'm speaking of. But once again, same thing that we're doing with IE8. If you're supplying a pixel value first in your stack and then supplying your VW unit afterwards, it's going to pick up the pixel, ignore the VW, and you're good to go. The only real messy issue is with WebKit browsers. WebKit browsers only calculate the VW size on page load or when an element is repainted. So it doesn't recalculate the size on page resize, which is why I was using Firefox in that last example there. You can get around this by using some JavaScript and causing a repaint to occur on elements that have fluid type size like this, and then target that just to WebKit browsers so that it's not running on every single browser. I'll typically use this by just using CSS and adding like a zoom 1 to my elements that have fluid type size. The performance impact is extremely negligible in that I can't notice it or see it in any automated testing, or just visually it's not there, and we get fully fluid type in WebKit browsers as well. You can find out more about the browser support by looking up viewport units on caniuse.com. And that's just about it. That's how we're using viewport units to make our typography in our websites just as fluid as our layouts and our imagery that goes along with it. It's pretty cool. We've used it on a couple sites now and have had no problems at all. Just with a couple little extra lines there in your CSS and a little bit of JavaScript, you can support all of the browsers that you may be supporting nowadays. It's pretty cool. Be sure to check back here on the website regularly. We're going to have more XI to I's. And until next time, thanks for checking this out. I'm Mike Gibson, and we're here at TableXI. Find us online at tablexi.com or on Twitter at TableXI.